We're live. What is this, Lady Ada?
Hey, everybody, and welcome to a knife-filled show and tell. Well, it's squishy. It's safe. Don't worry. This is a time when me, Lady Ada, and Mr. Lady Ada hang back and let you impress us with all your projects, whether it be 3D printing or LEDs or soldering or scanning electron microscopes. We'd like to see what you're working on for this half hour, 7:30 p.m. Eastern Time, every single Wednesday at the Adafruit Shop, Adafruit channel. But let's kick it off with some Adafruit peeps, and after that we'll call on others. Got to get out of here at 7:50, so take a couple minutes to your project, and keep your mic muted until it's time. And that goes double for the person named Mike. Your name is Mike. You will be muted until it's ready.
Okay, first up, Tony D, what are you spinning this week?
Hey, yeah, so I made a fidget spinner that has no moving parts at all. So it's using Circuit Playground or Circuit Playground Express. And this is an Arduino version, but I'm going to work on a CircuitPython version. And it's kind of cool. It uses the accelerometer, so it detects which side that you flick the fidget spinner from. So if I flick it from this side, then it can spin in one direction, whereas if I flick it from that side...
No whammies, no whammy stop.
Yep, exactly. Kind of slows it down. And of course, I can change the colors. I can change the type of animation. So if you want, the double spinner, hey, that one's kind of fancy. I like some of the colors I put in, like, multicolors. There's a gradient mode, so it's like a nice kind of smooth transition of colors for this one. So it's kind of neater, a little bit more subtle. This is more the refined fidget spinner. So definitely check out youtube.com/Adafruit. I have a little video on this, and then probably next week, early next week, I'll do a little guide. It's in the Circuit Playground library. So if you download the Circuit Playground library, it's the fidget spinner example. So load that up, and you're pretty much ready to go. Because nice thing with Circuit Playground, you got the lights, you got the accelerometer, everything's built in. So just plug it in, program it, and you're ready to go.
Okay, ready to fidget.
Fidget spinning in minutes.
Yep.
That is, it looks a lot more fun.
That's hard to say 10 times.
Yeah.
Fidget
No,
spinning.
it is cool. And no moving parts, which is, I think the only fidget spinner that can say that.
Okay, won't break.
Right on.
All right, next up.
Next up, Noah and Pedro.
Pedro.
Hey guys, we're back. Our internet is back, and so is our power. So hopefully you don't go out. I apologize to everybody on the morning where our stream went down, but we're back. Real quick, this project that showed off this week is this guy here, which it's kind of hard to see, but it's a little portable display. I just have HDMI here plugged into my Pi over there, and it has a 2500 milliamp LiPo battery and the power boost 1000C, so I can charge the battery. The main thing that makes the display work is, of course, the TFP401 display driver. We have a lot of them in different flavors. Some of them come with the screen. This one does not. This one's just the display driver, so it's a little bit more cost effective. And did he go to sleep? I think he went to sleep.
I see a little cursor in the corner.
There you go. Button. There we go. It'll come on. But anyway, yeah, that's this week's project. Really slim and just two-piece enclosure with minimal screws. Yeah, it's a nice upgrade, definitely. I kind of made it because I needed to design the TFP driver in Fusion for somebody who's working on a project. And I figured I might as well do the enclosure as well for it. So I came up with a little interesting way to mount the display with these little snap fit nubs. So that's this week's project. Hope you guys check it out.
And we'll show it on the show tonight too.
Yes. It's this week's project.
Awesome. Thanks.
Lovely.
Right. Next up, Aaron. Aaron, what you working on this week?
This week I'm doing mermaid stuff. I love to do mermaid stuff. I made a new necklace with a Circuit Playground. It's got a real seashell on it. And it is, let's see, I'm going to switch it on here. It's got a whole bunch of different modes. It's really pretty and a lot of fun. I've been wearing it constantly for the last 2 days, and just people keep stopping me in the street being like, why did you do that? So it's pretty fun. It just flips open like a little locket. And then inside you can push the buttons and change into different color modes. There's a brightness button right here. So you can make it super blindingly bright. It just steps up in 4 to 5 different brightness steps. Or you push the other button and you get some different color modes, which is pretty fun. I've got fire and ice and some different really fun ones. And then of course, since it's a mermaid necklace, I had to do the Little Mermaid Ariel voice reactive changing, which is pretty fun too. So I'm having a lot of fun with this right now, and that's what I'm working on.
All right. Looks awesome.
I like the combination of organic seashell and then electronics. It actually works. It's almost like they were made for each
It's
other.
exactly the right size.
Yeah.
You know, it's funny. It's of course because you're a mermaid. You have so many shells at home. I'm sure you're just like, I'm gonna go look at my shell collection.
That's right.
We have no shells at home.
Do you have any shells? No, zero
It's like
shells.
bass shell and like Z shell.
I just got this one in Hawaii I was in Hawaii last summer doing a photo shoot as Ariel the Mermaid, and we went shopping, and I got this one there. I'm like, I know I'm gonna use this. But that was I got it before the Circuit Playground even came out. So I got it and put it in the drawer, and then I just looked at it.
Perfect timing.
Excellent. All right,
Good
next
work,
up,
Past Mermaid.
Scott. What you got going on this week?
Hello. First off, sorry for last week. I was on my parents' Wi-Fi and, it didn't go so well. I just remember that. But today I'm plugged in, so it should be better.
Oh, good.
So over the weekend, I got distracted. I did a lot of hardware before I started working for Adafruit, and I had the hardware itch that I needed to scratch. So what I started doing was I designed a feather that has the RISC-V processor from Sci-Fi on it, which is the one on their Uno-shaped dev board that I've got. I've gotten Blinky working on that, and it's actually, they just announced at Maker Faire, Arduino's doing one, or they announced one as well. So that renewed my interest. I sent them an email and said, "Hey, could you send me samples?" And they were like, "Sure." So they come on Friday. And so I was like, oh, I better do something with it since I asked for samples. So I'll just screen share here real quick. And yeah, I can just share that screen. So this is KiCad. KiCad is an open source PCB design software, which I love and have used in my past life. And so this is the fully routed feather with the RISC-V chip on it. So
That's great.
This right here is the CMD21, which is the chip I've been doing tons of stuff. It's on all our M0 boards. And that's basically doing all the USB stuff for us. And then this, where there's no model, is a super fast SPI flash chip where all your code's stored. And I actually I noticed on their board that they actually have the traces the certain length. So I actually had to I can zoom in. I had to add these wiggles to try and make everything the same length, which was kind of fun and painful at the same time. And then this big chip here is the Sci-Fi Freedom E310, which is their first piece of silicon they have that does the RISC-V stuff. And I guess I should say RISC-V is a new CPU architecture, which is basically the language that the lowest level of your computer speaks, unlike x86 or ARM, for example. And then the backside is all blank. Well, there's no parts, but I did add 2 spots for the JTAG headers that we have in the store, so that if you want JTAG or SWD access to either one, which I use all the time, that's easy to get to as well. So yeah, I'll send that off probably during Ask an Engineer, and then a few weeks from now I'll get it from Osh Park.
Cool.
All right. It's not out yet. Don't ask. Live in motion.
It looks good.
Yeah, it's super fun.
All right. Next up, Sophie. Hello, Sophie. Welcome back to the show and tell. How are you?
Hi, good.
Hey, we can hear you.
Yeah.
Yay! So this is my Proton pack. I built it for Emerald City Comic Con, and I wore it there. It's only 95% done. There's another box that's going to go up here that I haven't built yet, and I would love to get sound into it. I know I have space to do that, but right now it's a giant NeoPixel ring in this part, in the back, and then this is actually the quad alphanumeric display. It's the same, it's the 3D printed knuckle ring project. I just built it into a box and then changed what it says. And this is just a voltmeter. And all the important stuff is in here. So I've got 2 trinkets and a power boost. And then actually I just wired everything up to this Herman proto board because I know I have more things I want to do to it. And I just think it'll be so much easier to just pull that out and solder to that instead of having to take all that other stuff back out. And then I've got my lipo, and then that's just one of those cell phone giant recharger batteries in there. And then this part, these are just 2 LEDs, and then I have NeoPixel sticks in the barrel, and this trigger just makes it kind of go all electrical crackly, like I'm busting a ghost.
Yeah.
And then most of this whole pack is actually plastic. It's like 3D printed or thermoplastic. I tried to keep as little metal on it as possible so that it would be light enough to wear all day. And it's only like 11 pounds. So it's really comfortable for what it is. And then I just made sure I could get back into all the little, anywhere I put electronics so I could get in and fix anything or upgrade anything. But yeah, that's the project pretty much.
This is great. I think
awesome.
I think we offered a show and tell sticker last week, but you can get another one too. Just email support
Yay.
at adafruit.com. And as this project evolves, come back because I think it sounds like you're going to put some sounds.
Yeah, I would love to. It's only ever going to probably be 99% done because there's going to be more stuff I want to add to it. So
The project's never done.
It'll be finished for an event, but it'll never be done.
exactly.
Outstanding. Good
Okay,
work.
cool.
All right, next up.
She's slowly zapping ghosts.
Stuff with Kirby. How you doing, Stuff with
Hey,
Kirby?
Kirby.
Hi. So this weekend I built a little weather cloud
Oh,
using a
cute.
Raspberry Pi Zero and a strip of NeoPixels. And then I milled out the case on my Shapeoko. So it checks the Yahoo Weather API and gets tomorrow's forecast. And then if the forecast is 10% hotter than today, it'll go red. If it's 10% colder or more, it'll go gold. But if it's within and not changing enough, it stays blue. And then if it's supposed to rain or snow, it'll blink. So once I cut it out, I had all the scrap from the middle. So then I just stained those also to kind of hang up on the wall with it. And then today I've been working on getting the code to work on other devices. So someone has a Blink or a Sense hat that works.
I'm digging it.
Outstanding. I like that it's really possible to make these ambient devices and it's how you want them to work. Not like, okay, I have to memorize what colors and sounds or whatever thing.
Yeah, maybe once spring comes around again, I'll make a jacket-shaped one, so I know if I need to take a jacket or a hoodie.
Yeah, I like that. Like in Boston, you know, we just visited, and at the top of the Prudential, they have just a single light, and it's actually supposed to be like for Red Sox games. So just blue means fair weather, blinking blue means rain.
Yeah.
Red means like cold or bad weather, and blinking red means like thunderstorms. And that's all you really need. Like the only 2 light colors and 2 modes gives you pretty much everything.
It's universal. Don't need to.
Is there a lookup table where you're like, oh, what's like amber?
Oh, look at that.
And this is just when I made a practice first out of just MDF, and I followed Tony's Techno Tiki guide so I could use the remote with it.
Oh, yeah.
So that was the
That's
first
super
try.
cool. All right. Well, outstanding work. Email support at adafruit.com. There's plenty of room for a sticker on multiple clouds and projects.
I like how everyone knows who you are now,
Yeah.
Kirby. It's clear.
All right.
You're Kirby.
Next up, Danon. How's it going?
Okay, go ahead.
Hi, Mia.
Hi, it's
Hi.
me, Mia. I would like to show the finished challenge Lady Ada gave me
Okay.
of a heart to program with sphero.
Okay.
Here's your phone. I got the phone.
Okay, go ahead.
I have to get out of your way.
Okay, later. Woo.
Out working.
It's a hard game.
She accidentally kicked the cardboard,
Okay, restart that.
so it kind of goofs a second. We got to reset.
No problem. I know, there's like a cat. Oh, goodness, this cat's going to be a problem. Look.
Get out of here.
Kitty knows. Kitty's like, this is interesting.
Scram, cat.
There you go.
Okay.
There we go.
Got rid of the cat. Let's see what the
Oh,
Out of the way.
telemetry. I want to see the telemetry.
Oh, wait, there's another cat.
oh, very
Midnight.
good.
Okay, you got it.
Yay!
Yay.
Okay, Midnight is my new cat.
Hey, cat.
All right, Mia. Well, excellent work.
Come here, cat.
Mia.
Nice job.
All
Okay,
right.
you ready for your next
Thank
task?
Thank you.
Are you ready for your next homework assignment?
Yes.
Okay, next time I want you to make a cat head shape with the 2 ears.
Oh, dude, that's awesome.
Yeah. Okay, can you do that? Because you got 2 cats. You gotta like cats.
I'm using this head.
Yeah, you can take that in. It's
You
fine.
get that cat head. So yeah, I want it to be like, there's like the chin and then the ear comes up and then it does the other ear. So you got to do both ears. Just catch it.
All
I think you
right.
can do it.
Well, email support@adafruit.com and we'll send you and the feline of your choice as seen on the show and tell sticker.
Sticker, yeah, bitch.
All
Okay.
right.
Too
next
much
up.
fun.
Okay, Mike. How's it going, Mike?
Am I?
Hey, Mike.
Yep.
Oh, hi. My project is a display for a Bluetooth heart rate monitor using the NRF52 in client or central mode and a TFT feather wing. So here's the feather wing with the NRF52 on the back. And then for testing and for this demo, I'm using the Feather M0 Bluefruit with an OLED on it. So I'll plug in the Feather M0 and it'll start displaying.
Yeah.
So it's simulating the heart rate, or is it?
Right. It's simulating it. I've tested it with an actual Bluetooth chest strap heart rate monitor, and it worked with that as well. So now I'll plug in the NRF or the NRF52, and it'll.
Oh, cool!
That's cool.
Wow, nice animations there.
Yeah.
And you got central mode working.
Yeah, the examples for the UART example helped me a lot. So basically followed that. And then if I disconnect the M0, it should change the symbol on the the Bluetooth symbol showing it's disconnected.
Wow, excellent job. This is a great example.
That works
Nice
better
work.
than like a dozen Bluetooth things I've owned or at a car that did Bluetooth once and none of it worked. This is better.
Yeah, that was like really fast.
Yeah, it syncs up pretty fast. And then I want to have it keep a list of what it's connected to before, because after I tested it with the actual chest strap heart rate monitor, I couldn't get it back to connecting to the M0. It kept wanting to connect to that one.
Oh yeah,
right.
because
So then you
it's
could
like linked
display.
up to it. All right. Well, you got touch screen, so you could have even
Yeah.
a list of all the things and.
Right, exactly.
Sweet. All right. Well, nice work with this project, and
Yeah.
welcome to Show and Tell. Thanks for coming by.
Yeah, outstanding. Email support@adafruit.com and we'll send you out as seen on the show and tell sticker. You can stick it on you on the back of that, whatever.
On your heart. And
Yeah.
if you have code or something or a web page where this is, I think people would really be interested. A lot of people ask us for central mode examples, and
Yeah,
if
that'd be
you
cool.
post it up, we'll blog it up and people can check
Okay.
it out.
Yeah, once I did this first one, I already I've been working on doing the cycling speed and cadence sensor too, and I have that mostly working too.
Awesome.
So.
Very cool. Good
All
work,
right.
Mike.
Thank you so much, Mike.
All right. Adam, welcome back. Adam, how are you doing with your scan electron microscope?
That's an interesting question. So,
An interesting answer.
yeah. First of all, cheap ESR meter straight from Shenzhen, likely a horrible idea. Seeing as I'm going to share screens to show you guys. I have capacitors that have spewed their electrolyte all over my board, and it still measured as passing on ESR and voltage leak and good capacitance, which is disconcerting because this is a bypass capacitor on the switch mode regulator, and the switch mode regulators have all been sequentially blowing up. This is the handful of fuses and transistors I've gone through for this thing so far. So that's a combination of the high voltage or the electron gun high voltage drive transistors and the 75 volt rail transistors, and along with all the fuses I use to diagnose that. So I've just started buying bigger and bigger packs of fuses. I've decided I'm going to call them single-use troubleshooting devices at this point because that's what they are. So like you can see, I'm starting to find more and more bulged caps that I put a new power. So I've got multiple of these. I gotta get back to this tab. I have multiple of these driver boards. So this microscope is very modular. So I swapped one of these out. All the capacitors looked great on it when I put it in, and they all came out looking horrible. So I've learned I've really got to start doing better tests under power on all the components before I really start to get all the subsystems together. But at this point, I'm done with these capacitors and replacing them all. I don't care if the ESR meter says they pass, because I don't trust that anymore, because it is telling me that evidently bad caps are very good. And the other big thing that happened was I did it again, and I bought another piece of high vacuum equipment. This time it's a helium leak detector. This thing uses basically a mass spectrometer inside to detect when helium penetrates a vacuum chamber. but I don't think the helium leak detector portion of it works. It's got a whole nother ultra high vacuum system, which is really great because I want to start doing my own sample preparation, or when I get the microscope working, you have to prepare samples in special ways. You can't, with this thing, image a non-conductive sample. So what you have to do is build some sort of chamber to image it. So using all of this high vacuum components in here, I'll be able to build a chamber that I can use to, in a high vacuum environment, coat metal onto non-conductive samples and let me sample them with a microscope. So hopefully I'll be picking that thing up on Friday or Monday. I got a really crazy good deal on eBay. I'm surprised it was up for as long as it was for the price, but I don't know why. I got it for a good deal. I'm happy with it. So
yeah, and
it's gonna be
I like to have dueling projects that I rebel against.
Can you say that again?
Oh, I like to have dueling projects that I rebel against. Like when one frustrates me, I'm just like, well, I'll just go work on this other complicated thing that frustrates me, and then I just go back and forth between the two.
Yeah, well, these are both kind of one of the same projects. They have almost all the same components in them, and were built at the same time.
Yeah.
So we'll see how that is. I've had a lot of beyond this project too, just a ton of experience dealing with high vacuum systems in bad ways. So I haven't really had a chance to do much else besides dealing with high vacuum systems in bad ways. So
yeah, we're going to probably make a high vacuum system badge just for you. We're awarded to one person. All right, Adam, well, keep up the good work, and good luck on your single-use tester project.
Thank you. It's great.
All right. Next up, C. Scott. C. Scott. Hello.
Oh, hey, guys. Hear me all right?
Yeah.
Testing. Okay. Just a quick update. I'd hoped I'd have my Melzi replacement boards back by now, but they're still in over at Seed. Hopefully next week. But a couple of things that I was thinking about. I saw one of your live broadcasts where you were soldering something, and I noticed you were SMT soldering with a tip that kind of looked like this. This is off a Weller WSD51, which is a fairly common. It's one of these that has the magnetic slug in it, and it reaches the Curie point, and that's how it achieves its temperature control. But yeah, a nice all-around tip. But if you're soldering these 1/2 millimeter pitch things, you need a tip more like this. This is a 1/2 millimeter tip. It's hard for me to get it in focus. I get it focused back here, but then you won't be able to see it. I like these because this is a cartridge. It just plugs in my iron. Like here's my standard tip one for desoldering through-hole parts. It plugs into the very same iron. You just set the temperature and go. This is a JBC model. I've had it for probably 18 or 19 years. It works really well, but worth investing in if you're going to do fine pitch work, because it's a lot better than blobbing a ton of solder on your pens and then having to wick it up. I don't like putting any more heat on these parts. I mean, I know they can go through a reflow oven, but they're really designed for a constant heat flow, not lots of heat in spot areas. I've seen it actually damage the chip if you uncap it. Anyway, just an aside, somebody wanted to see what the back of the, this is the hyperbolic tangent, this is my soft clipping mixer. They wanted to see how I put it together, and you can see there's a host board that has the Jackson and the pots on it, and then this board in the back is the actual electronics. It has the mixer and the VCA circuits and the diode clipping rings, and then they're held together by these 12 millimeter nylon board locks. I like using those because you don't have to spend hours fiddling with mounting hardware. Anyway, and lastly, I'm still building Kickstarter units. This is the latest one, all ready to go, and more next week. That's what I'm up to.
Okay.
Outstanding. All right, thank you so much,
Party.
Aaron, Midnight Cat, Mia, Scott. Every single week, Wednesdays, 7:30 p.m. And thank you for making this the best half an hour of our week, every single week, everyone. Ask an Engineer starts in like 5 minutes.
Thanks, everybody.
Bye-bye.
Bye.